If you haven't viewed part 1 about the different ways electrons can be shared between atoms, then you might want to view that before you watch this video. In our experiment, we want to see what happens when we combine oil with water. Oil is made up of molecules that have mostly carbon and hydrogen bonds. We can represent the oil molecules like this. Remember methane? Did the carbon and hydrogen bonds share electrons equally or unequally? The carbon and hydrogen bonds have evenly distributed electrons. So there were no parts of methane, and there are no parts in our oil molecules that have slightly or positive or slightly negative charges. But what about the water? Do the hydrogen and oxygen atoms share equally or unequally? They share them unequally. So there are parts that are slightly charged. Let's see what happens when the oil and water are combined. The water molecules are very attracted to each other because of those partial charges. The oil molecules don't have any slightly positive or slightly negative areas, so the water isn't very attracted to those. They're more attracted to each other. In the same way, the oil molecules are more attracted to the other oil molecules because the oil molecules don't have any partial positive or partial negative charges. Let's see what happens if I shake it up. Once I stop shaking it, the water molecules and the oil molecules separate back into their respective layers. So because there are no positive or negative areas on the oil molecules, they're attracted to each other, and the water molecules, with their partial positive and partial negative charges, are attracted to each other. So they tend to separate. Let's do another experiment. This time we'll mix water and acetone. Acetone is the main ingredient in nail polish remover. Here's a drawing to represent the bonding in acetone. It has some carbon atoms, which are bonded to hydrogen atoms, and it has an oxygen atom bonded to a carbon atom. This carbon and oxygen bond is interesting because it's a double bond. That means it shares two pairs of electrons. But how does it share the electrons? Equally or unequally? If we look at a periodic table labeled with the electronegativities again, and find the carbon and oxygen, we see there's a pretty big difference in their electronegativities. Oxygen can pull the electrons much more than the carbon. So what do you think? Will this be a bond where the electrons are shared equally or unequally? Because oxygen has a much higher electronegativity, they will be unequally shared in the double bond. The oxygen will pull the electrons closer to it. So will acetone have a balanced distribution of electrons or an unbalanced distribution of electrons? Acetone's unbalanced distribution of electrons gives it a slightly negative area and a slightly positive area on the molecule. So do you think acetone will mix with water, which also has the imbalance in charge? Let's find out. So what do you think? Will the acetone and water mix? You have a lot of options to pick from. Yes, they will mix and we won't see any layers. They will maybe sort of mix, but we'll still see a little bit of layering. Or no, they won't mix at all, and we'll see distinct separate layers. Or you can always say, I still don't really know. It's okay in science to say I don't know, because that's why we do the experiment. Right away, you notice when I pour the two together, they don't form separate layers. And when I shake them, they don't separate back out. So if we compare and look back at the oil and water, we can see how the two layers are still there, but the acetone and water mixture isn't forming any layers. So if you picked A, that yes, they will mix and there will be no layers, you were right. Why don't they form layers? Well, the acetone, remember, has the carbon and oxygen double bond. And because the carbon and oxygen have such different electronegativities, the oxygen can pull those electrons, and the electrons are unevenly distributed toward the oxygen. And that creates a partial area of partial charge on the oxygen and an area of partial positive charge on the carbon, just like the water has on the oxygen and hydrogen. Because both the water and the acetone have areas of positive and negative charges, they're able to attract to each other. So the areas of positive on acetone can attract to the areas of negative on water and vice versa. And that's what allows them to mix together.